Okay, so let's continue our discussion on operating systems. Now we will talk about process. Okay, so let's first understand what exactly is process. Say for an example, you have written a C program in Notepad. So अभी आपके पास फाइल है sample.c. So this is basically file residing on a disk. But the moment you run this program via GCC compiler, this would become process. So we can say that process is program under execution. This is the most simple definition of process. Program under execution. Okay, so now let's say you have a program of Chrome. Now there are multiple tabs open on your Chrome. ठीक है? So the same program will have multiple processes. So for a single Chrome, you would have multiple processes. That means that a single program can have multiple processes at the same time. Is that clear? Yeah. So now let's talk about process control block. Process control, process control block, or also known as PCB. Now what is PCB? PCB, we can take it as an analogy of Aadhaar card. PCB is Aadhaar card of process. It will have all the information regarding the process. So what all would be the information that would be stored in the PCB? Well, the first one would be process ID. Every process will have unique process ID so that it is easy to identify which process is going on at what point of time. Then the second content of PCB is process state. Process state. This will store the state of the process. Now, what would be the state of the process? Ready, running, waiting, etc. We'll talk about each of these states in detail in the later portion of this video. Then, the another component is program counter. Program counter or PC. What will the program counter store? Well, the program counter would point to the next instruction to execute. Because see, एक program है, this would have multiple processes, and each of this process would have multiple instructions. So program counter would point to next instruction. I hope it's clear. Then another component of PCB is CPU registers. Now, as you might have learned in the subject of computer architecture, जो भी execution होता है, that would be done in the hardware devices known as registers. So register would be assigned to a particular process. So CPU register की जो information है, that would be stored in the process control block. Then memory information. And the last two components would be input output status and accounting information. IO status and accounting info. Input output status would tell the list of input output devices allocated. Say for an example, if your process is Call of Duty, then what input output devices would it need? Well, of course, it would need monitor, it would need keyboard, it would need your headset, it would need your mouse. So all those information would be stored in the input output status, that which of the following input output device is currently in use, which we need to use. And in the accounting information, we would have information regarding the time used, regarding the priority. Accounting information, time used. We will see about these topics in the process scheduling in the later videos. So yeah, time used and priority. So like say for an example, if you are running Call of Duty, you have pirated application in your laptop. And at that time, your firewall needs to tell you that this is not the right application for your laptop. So at that time, the process of firewall should given more priority because that is more important. The safety of your device is more important. So the priority of a particular process would be mentioned in the PCB. So these are the 7 major components of PCB. Let's just go through each one of them again. So first one is process ID, then process state, and program counter, which will point to the next instruction. Then CPU register allocated, memory information. Memory information, it will store the limit address or page tables. We'll talk about page tables in paging portion of the operating systems. So basically it will store that in which page table this particular process is allocated and other stuff like uh, it would store the base limit address of those particular pages. So that would be in the memory information, then input output status, then accounting information. So these are the major contents of process control block. Now let's talk about process states. Process states. Now let's take an analogy of our life cycle. We would be when we take birth, we would be in the न्यू स्टेट नाउ जब तक हम लोग रेडी होते हैं काम काज करने के लिए व्हेन वी get the enough amount of experience when we study enough stuff to do a job then we would say that yes I'm ready to work so we would go into the ready stage now when you sit for the placements or when you go for off campus like these are just the vague examples you would go from ready to running state you would be doing work or you would be doing a job or you would be performing some task. So that would be running state. Now let's say while you are in learning stage, say for an example, you need to take a maternity leave. So that would be wait stage because you won't be working at that particular time, right? So that would be wait stage. And when you are done with your maternity leave, you will say that, yeah, I'm again ready to do the work. And then from then you would again start working. Now this will continue until you take the retirement. And when will you take the retirement? When you are done with your job, when you are satisfied, when you have enough amount of money, then you will go to terminated stage. So that is what goes on with process. When a new process is created, it will first be admitted and it would be sent to ready stage. Now when a process is ready to run, a scheduler will dispatch the process to send it to the running stage. So scheduler dispatch. Now when there is a need of input output, we will go into the wait stage. So IO event or waiting stage. So this would be input output event. Then we will move to the waiting stage and when we are done with the waiting, we would go to IO event or completion like IO event is done. Where is the pointer? IO done. When you are done with the input output, you will again go to the ready stage. Now say for an example, when you are in the running stage, some higher priority process occurs. Say for an example, it's a bad example, but say for an example, someone dies in your family, then you need to stop working right now and you need to go back because the priority of the other thing is more. So that would be interact. So I hope all these states of the processes are clear. Okay, so as we saw in the process states that to move from ready state to running state, scheduler will dispatch the process, right? But what exactly is the scheduler and why do we need the scheduler? Let's talk about the scheduler. Why do we need the scheduler? Well, there are multiple processes which are ready to run, but the CPU can only run one process or few at a time if it's a multi-core CPU, right? So a scheduler should ensure these things. It should ensure fairness, that is, no starvation. कोई भी प्रोसेस इनफाइनाइट टाइम के लिए वेटिंग में नहीं चली जानी चाहिए। क्यों? क्योंकि दूसरी प्रोसेस रन हो रही। देन इट शुड इंश्योर द एफिशिएंसी। We'll see about the waiting time, the completion time, the turnaround time in the later portion. But efficiency मतलब कि CPU जो आपका है उसका maximum utilization होना चाहिए, और average waiting time और वो सब should be as minimum as possible. That comes under responsiveness. मतलब कि waiting time should be less and the throughput should be more. The throughput. थ्रूपुट मतलब मोर प्रोसेसेस। थ्रूपुट ज़्यादा होना चाहिए मतलब मोर प्रोसेसेस should be executed in the same amount of time or less amount of time. I hope why do we need scheduler is clear, right? So this explains why do we need these schedulers. Now let's move on to the portion where it explains what is scheduler. Well, talking about schedulers, scheduler is a component of OS which will make sure about all these points. It is a component which will take care of fairness, it will take care of efficiency, it will take care of responsiveness, it will take care of throughput. So it is a component of OS which will take care of the above discussed points. So in short, scheduler will decide which process should run next on the CPU from the list of ready processes. Think of it as a traffic controller at a busy airport. It will decide which plane will get to take off or which plane would be waiting. So that is the basic task done by scheduler. Now there are various types of schedulers. Let's talk about each one of them in detail. Types of schedulers. The first type of scheduler is long-term scheduler. Okay, by the way, scheduler works on each of the states of this process. It's not just ready to running. It will take care of new to ready, running to wait, running to terminated. All of this would be done by scheduler. So don't fit in the mind that it works just for the two states. Okay, let's talk about long-term scheduler. Well, it will decide which processes are admitted to this system. It will decide which should be admitted, which processes should be admitted. This portion will not work very frequently in the operating system. It will control the degree of multi-program. Degree of multi-program. So that कि कितनी process allocate होनी चाहिए at a single time in the memory so that degree of multi-programming is maintained और कोई भी process starvation में नहीं जानी चाहिए. This scheduler runs less frequently. Well, you may not find long-term schedulers in the modern operating systems like Windows, Linux, or Mac, but it is found in the older versions of the operating systems. So, yeah, we don't usually have long-term schedulers at present in the modern operating systems. Now, let's talk about the second type of schedulers, which is short-term scheduler. It is most important type of scheduler. Now, why I say that it's the most important scheduler? Well, it picks one of the ready processes to run. It picks one of the ready processes to make it from ready stage to a running stage. यार क्या bluff मारे sorry. Okay, so why the short-term scheduler is most important? Well, it will decide which ready process will run. It will run very frequently and it is responsible for context switching. It is like a cashier deciding who gets served next from the queue. So let me list down the important properties of short-term scheduler. It will pick ready process. Another point is it will run very frequently. It will run frequently, and short-term scheduler is responsible for context switching. Okay, now let's move on to the third type of scheduler, which is medium-term scheduler. Well, medium-term scheduler is kind of a swap. So it will temporarily remove processes from RAM and to reduce it will temporarily okay. So we can say medium term scheduler as a swapper because it will temporarily जी, चले जा. So yeah. So why do we say it as swapper? Because it temporarily removes processes from memory to reduce the load. Later, it may bring them back into the process. It helps to manage the limited memory and it is found in systems with virtual memory. We can think of it like asking someone to wait outside if the restaurant is too full and calling them back later. So basically, it will help to manage memory. It will swap from ready to running to ready. Yeah, that's it about medium-term scheduler. So let me pin down the differences between all three. Let me summarize. So the role of long-term scheduler is to select job to load into a RAM. It is very infrequent. You can take the real-life analogy of restaurant host. The short-term scheduler, it will choose the process for CPU. It will be running very frequently, and the medium-term scheduler would swap the processes in and out of the RAM, and the frequency of the medium-term scheduler is occasional. Now, when we talk about all these schedulers, we will bring the process, we will change the process. The scheduling is basically done using scheduling algorithms. And there are various scheduling algorithms like FCFS, first come first serve, shortest job first, and many more round robin. We'll discuss about each of the scheduling algorithms in the later videos. Okay, so let's discuss what is dispatcher. Now, as we saw that जो भी शेड्यूलर्स हैं हमारे वो शेड्यूल करते हैं कि कौन सी प्रोसेस कब रन होगी तो वो डिसाइड हो गया उसके बाद डिस्पैचर इज द कंपोनेंट it is the component of OS which will give the CPU to those processes. So the dispatcher is a component of the OS that gives the control of CPU to the processes. So in simple words, scheduler will choose the process and dispatcher will actually start the process. I hope dispatcher is clear. Okay. After dispatcher, let's move on. Okay. First of all, let's discuss what are the various responsibilities of dispatcher. The first one is context switch. We'll discuss this after this topic. And second responsibility is switching to user mode. We discussed previously the user mode and kernel mode. So like the OS shifts the CPU from privileged kernel mode to user mode whenever the process needs to run. And तीसरी responsibility है jumping to correct instruction. एग्जैक्टली इंस्ट्रक्शन और वो सब क्या है पेजिंग में फ्रेमिंग में वो सब हम देखेंगे व्हेन वी विल डिस्कस द पेजिंग बट राइट नाउ लेट्स जस्ट कीप इन माइंड दैट दीज आर द रिस्पांसिबिलिटीज ऑफ द डिस्पैच नाउ लेट्स लर्न अबाउट कॉन्टेक्स्ट स्विच होता क्या है, कैसे होता है, वो सब हम देखेंगे. लेट मी शो यू अ डायग्राम. ओके, so as we can see here, let me change the color. Okay, as we can see here कि प्रोसेस पी नॉट यहाँ पे एग्जीक्यूट हो रही है. अभी जैसे ही सिस्टम कॉल या इंटरप्ट होगा, ये जो प्रोसेस पी नॉट है उसका जो स्टेट होगा वो पीसीबी में स्टोर हो जाएगा. पीसीबी क्या है वो हमने पहले देखा. देन अगली प्रोसेस कौन सी लोड होने वाली है, P1. तो P1 का स्टेट है वो रीलोड होगा और फिर P1 एग्जीक्यूट होने लगेगी. और फिर जैसे ही दूसरा इंटरप्ट अकर हुआ, P1 का जो स्टेट है वो सेव हो जाएगा पीसीबी में. और जो दूसरी प्रोसेस है, इधर प्रोसेस पी नॉट का ही एग्जांपल लिया है, लेकिन से फॉर एन एग्जांपल प्रोसेस P2 है, तो P2 का जो स्टेट है वो वहाँ यहाँ पे लोड हो जाएगा एंड देन P2 विल स्टार्ट एग्जीक्यूटिंग. तो इन दिस वे कॉन्टेक्स्ट स्विच विल टेक प्लेस और इस तरह पीसीबी में स्टेट और वो सब सेव होगा और ऐसे ही आगे चलता जाएगा. सो इफ वी समराइज, context switching is the process of saving the state of currently running process and loading the state of the next process that needs to run on the CPU. The technical definition है, but if you got to know about these things through this diagram, then it is good enough to know कि context switching क्या होता है और क्यों चाहिए. Okay, next small topic is IO bound process and CPU bound process. IO bound and CPU bound. तो बेसिकली क्या होता है कि कोई भी प्रोसेस होती है वो सीपीयू में रन होती है, फिर या तो वो वेट करती है. जैसे ही प्रोसेस सीपीयू के अंदर आई, इधर इट विल वेट और इट विल बी एग्जीक्यूटेड. अभी वो वेट कुछ भी हो सकता है, इनपुट आउटपुट के लिए वेट हो सकता है, कोई दूसरी प्रोसेस आ गई तो उस वजह से वेट हो सकता है. लेकिन बेसिकली प्रोसेस के दो ही स्टेट होंगे, या तो वो वेट करता, नॉट एक्जैक्टली टू स्टेट्स बट अभी के लिए समझ लो कि इधर प्रोसेस would be in CPU executing itself or it would be waiting. So whenever a process spends more of its time in input output process while waiting, that process is known as IO bound process. और जो प्रोसेस सबसे ज्यादा टाइम सीपीयू के अंदर डालती है उसको हम बोलते हैं सीपीयू बाउंड प्रोसेस. आई होप ये समझ आ गया होगा.